In this video, we are going to analyze in detail and compare two types of compressors used in automotive air conditioning systems: the traditional compressor with mechanical clutch and the modern electric compressor for climate control. Throughout the analysis, we will see how they differ in operation, performance, maintenance, and costs, as well as the impact they have on vehicle efficiency. 1. Power source. The electric compressor is powered exclusively by electricity through the battery and the alternator. Its great advantage is that it does not depend directly on the gasoline engine to operate. On the other hand, the traditional compressor with clutch obtains all its power from the mechanical drag generated by the engine through a belt. This means that its operation is limited by the performance of the thermal engine. In the case of some high-capacity electric compressors, it is important to consider that they might require a higher power alternator to meet their energy demand. 2. Operating speed. The electric compressor works at a variable speed that is electronically controlled precisely according to the cooling demand. This allows it to operate exactly at the power required at any given moment. In contrast, the traditional compressor with clutch is directly linked to engine revolutions. If the engine spins faster, the compressor does too, and if the engine runs slower, the compressor performance decreases. 3. Operation with engine off. One of the most notable advantages of the electric compressor is that it can continue cooling the cabin even when the engine is stopped, which is essential in hybrid or electric vehicles, or when waiting at a traffic light in high temperatures. In contrast, the traditional compressor stops working completely as soon as the combustion engine is turned off. 4. Fuel consumption and alternator load. In terms of consumption, the electric compressor does not exert mechanical load on the combustion engine, which can reduce fuel consumption compared to the traditional system. However, it does increase the demand on the alternator, which in turn consumes engine power. Despite this, its electronic cooling production control helps avoid excess by generating only the necessary amount of cooling. The traditional compressor, on the other hand, transmits a direct load to the engine through the belt, which increases fuel consumption and sometimes produces more cooling than necessary, wasting energy. 5. Operation at low RPM. In heavy traffic, or when running at low revolutions, the electric compressor maintains its efficiency consistently thanks to its independent control from the engine. The traditional compressor, on the other hand, loses cooling capacity at low RPM, which can be uncomfortable on hot days when the vehicle is stopped or moving slowly. 6. Noise and vibrations. In terms of comfort, the electric compressor is usually much quieter and generates fewer vibrations than the traditional system. This contributes to a more pleasant driving experience and reduces wear on other vehicle components. 7. Maintenance. Regarding maintenance, the electric compressor requires fewer mechanical interventions since it does not have a clutch or drive belt. However, if it fails, repair is complex, and in many cases a full replacement is chosen. The traditional compressor, on the other hand, requires periodic checks of the belt, clutch, and seals, but its repairs are usually simpler and less expensive. 8. Spare parts availability. Currently, spare parts for electric compressors are not as abundant, and their price tends to be higher, partly because it is a newer and more specialized technology. On the other hand, traditional compressors have a wide range of parts available, which facilitates repairs and reduces waiting times. 9. Initial cost. The purchase and installation price of an electric compressor is usually considerably higher due to its advanced technology and the need for compatible control systems. The traditional compressor, on the other hand, has a lower initial cost and does not require major modifications for installation in vehicles that already use it. 10. Control technology. The electric compressor is managed by intelligent electronic modules, that receive real-time data from temperature, pressure, and other system sensors. This allows it to adjust its performance precisely and efficiently. In contrast, the traditional compressor is controlled by a mechanical system that activates or deactivates the clutch according to demand, which is less precise and more prone to abrupt on and off cycles. 11. Weight. In some cases, the electric compressor can be lighter than the traditional one, since it does not require a clutch or pulley. This can contribute to a slight reduction in the overall weight of the vehicle, although the difference is not always significant. 12. Impact on emissions. By optimizing energy consumption and operating only when necessary, the electric compressor can contribute to an indirect reduction in pollutant emissions, especially in hybrid or electric vehicles. On the other hand, the traditional compressor, by increasing the mechanical load on the engine, tends to increase fuel consumption and therefore emissions. 13. System complexity. The electric compressor has greater complexity in the electronic part as it integrates controllers, sensors, and internal protections. However, its mechanical design is simpler than that of the traditional compressor. The latter, although electronically simpler, has a more complex mechanical system with clutch, pulley, and internal mechanisms subject to wear. 14. Repairability. In terms of repairability, the electric compressor is more limited. Many times it cannot be repaired economically, and the most viable solution is full replacement. In the case of the traditional compressor, it is possible to repair or even rebuild it, making it a more attractive option in terms of long-term maintenance.